Hey guys, it's Matt from the Rabbit ECU project here, and today I'd like to talk a little bit about the MapMate configuration settings window. So this is basically the place where you can set up your crank and cam sensor, the configuration of the sensor, and also the pattern that's you expect of the cam and crank trigger wheels. So I'm working on the bench today, and I've already uploaded the base file, the base calibration out of the Rabbit ECU, which you can see here. You might recognize that as a 60-2 variable reluctor signal. So if we look at the settings on the right, these combo drop-down boxes, first up is the primary edge setup. Primary edge meaning the crank angle sensor. And because we're using a variable reluctance crank sensor here, these are typically configured on the falling edge, hence why falling is selected. You do have the option of running off the rising edge, which you do occasionally see on some European cars. And there is an option to trigger off either edge, which is quite often used for either Hall effect or optical sensors. So those same settings apply for the secondary edge, which refers to the cam sensor pattern. So the cam sensor pattern here in blue, that's just the generic pattern that we're looking at today. And actually we're probably just considering our wasted spark setups today, so the cam sensor really isn't relevant. So if you're using a VR sensor on your crank or cam, you do need to enable it here. And a side effect also of enabling the VR circuit within the Rabbit ECU is that disengages the pull-up resistors that are required for either a Hall effect or an optical sensor. So ditto for the cam sensor, you do need to select whether or not you're using VR or Hall effect. These next two settings, they don't apply today because we're using a VR sensor. They only really apply for Hall effect / optical. The next setting is the trigger type. So the Rabbit ECU firmware is able to look at this programmed crank angle sensor pattern and determine a few things. One of them would be how many teeth there are per revolution of the engine, and also the position of missing teeth within the pattern. So you can see on this crank angle sensor, it's a 60-2, and there's 2 teeth missing. So that's able to automatically detect that if you just switch the trigger type to auto. So moving along to sync phase repeats. Basically, this setting allows you to run either sequential or direct fire injection if you choose to. First of all, today I'm just going to look at a batch fire injection with wasted spark, hence why this setting is set to batch. The next setting is the ignition tooth timing enable. So on these multi-tooth trigger wheels, it's possible to schedule the ignition timing actually off every single edge of the crank sensor pattern. In this case, 60-2 crank angle sensor, that means that every 6 degrees, the timing can be calculated and delivered fairly accurately. So if I jump across to the oscilloscope here, you can see the system actually running, and if I zoom in a little bit more, you can see that the ignition timing, the falling edge, this is the igniter signal, is very tightly aligned with the falling edge of one of these crank angle sensor teeth. So being able to schedule every tooth gives you a very high degree of accuracy with the ignition timing. So just jumping back to MapMate. The next setting is the manifold volume. That doesn't apply today because that's for throttle body injection applications. I think the cylinder CCs and cylinder count is fairly self-explanatory. So let's just take a look at the timing main offset. Basically, the timing main offset refers to whereabouts the origin of this crank angle sensor pattern falls within the 720 degrees of the engine cycle.